Archiving started. Hello. This learning unit is hand tool design selection and the study of vibration. My name is Teresa Stack. I am an assistant professor with Montana Tech of the University of Montana, and this course satisfies the requirement for the Master of Science in Industrial Hygiene. Since the beginning of human existence, tools have played a key role in the development of culture and industry. Use of hand tools is thought to be an initial sign of intelligent life, separating humans from other mammals. Currently, however, many hand tool designs and practices do not incorporate modern accomplishments in science and technology. Tools serve as an extension of the human hand for improved manipulation and power. Many tools have been designed with the primary consideration of accomplishing the task rather than considering the effects on the operator's upper extremities and body. In this training unit, you'll understand the key principles that affect the selection and performance of hand tools, or how the worker performs when they're using their hand tools. You should be able to ultimately make informed decisions when selecting hand tools, and finally inform workers with what some of the risk factors are associated with using powered and non-powered hand tools to limit or control their exposure. On Moodle, there is a hand tool evaluation form, which is the one that you see here. These are based on sound ergonomic principles and the ACGIH guidelines for hand tool selection and vibration exposure. And you can print it off now and follow along with the lecture. Most of these items are covered, although not necessarily in the order that you see. And you'll be later on using this tool to evaluate a hand tool for one of your learning assessments. So you can find this right on Moodle. Non-powered hand tools are widely used in a variety of industries, including construction, manufacturing, and agriculture. National data suggests that a large number of injuries known as musculoskeletal disorders are attributable to hand tool use in most of these occupational settings. To the untrained eye, however, it may be difficult to evaluate tools from an ergonomic point of view. The purpose here is to take that process and make it much simpler for you so that you can not only evaluate what factors are causing high hand forces or high muscular stress, but also to see how you can put simple solutions in place. So in selecting our hand tools, typically the main objectives are to maximize performance of the tool and the worker, to enhance work quality so that the part that we're cutting into or refinishing is of the highest quality, and that quality is repeatable across different workers, and as well as to minimize physical stress or fatigue on the operator. The example that you see here, the picture at the top, this gentleman was using a very large, heavy chop saw to cut through a piece of water conduit. And although he's doing it on a set of workhorses, typically this work would be done below grade if a water main had broken and you'd be in a trench. And the operation was extremely physically tiring. The chop saw is heavy. It's in that 15-pound category. And the solution that they put into place was this remote high-speed utility pipe cutter that you see in the black and white picture. So after making a small cut in the pipe, whether it be plastic or cement, you drop the cutting blade into place, wrap a chain around the outside diameter of the outside circumference of the pipe, and then you can turn the saw on and it will somewhat remotely cut the pipe. And so this would eliminate the worker's exposure to awkward postures as well as vibration exposure. So when we are working with our hand tools, we can be in all sorts of different body postures, and those body postures will either contribute to or reduce the amount of muscle strain that we have. So in our standing worker, you can see that this worker is up above shoulder height, and for his best posture, he should be there in about elbow height or slightly above. And you can think about ways in which we can either elevate the worker, because it would be really hard to bring the worker down into a lower position. Now our squatted worker, you can really see some of the problems with working with hand tools as the debris tends to fly right in our face because that's where our hands are sitting. And for this worker, maybe we can get him on a low kind of stool so we can get him out of that crouched posture. And that's some of the solutions that you see here. The picture of the gentleman that looks like he's on a recliner, that is a really neat piece of equipment. I think you also saw this same picture in workstation design. This chair goes up to 6 feet high, so you can have people who are working under an item. This gentleman happens to be under an aircraft that is up high above the ground. But if he's able to sit in a seated posture because it doesn't have to generate a lot of forces, then the chair can lean back and get him into a more neutral position. And then the picture that you see on the left, this is a lean stool. So although the worker has to lean back, he's in a more neutral posture. The lean stool takes about 2/3 of the body weight or the forces off of the lower back. And you can see that his ears are over his shoulders, and his shoulders are more so over his hips, even though he still is leaning back. So there definitely is some other workplace considerations for worker positioning. Remember how important posture is to the overall working environment, and we can change somebody's posture by raising or lowering the worker, by raising or lowering the work surface, or by raising or lowering the work piece, whatever it is that the workers are working on. So some way to orient that work towards the worker so we don't have to bend our bodies to reach the piece or part that we're working on. So some typical problems with hand tools can be awkward postures. Postures that are outside of neutral can strain the neck, shoulders, elbows, wrist, hands, or back. Bending, stooping, twisting, and reaching are examples of awkward posture. Power grip, the hand grip that provides maximum hand power for high tasks is the power grip, and I'll show you this in a second. So one of the problems would be using the wrong grip for the particular task. Contact pressure, pressure from a hard surface, point or edge that is coming in contact with the hand. This can, of course, directly compress tendons, ligaments, or blood vessels because they run very close to the surface of the hand in the palm, as well as having the wrist in a bent or awkward position. So the best tool is one that fits the job that you're doing, fits the workspace that's available, reduces the amount of force in which the worker has to exert, and also fits the hand. So we want to know the job that people are working in, look at the space in which they need to be able to access the part or the screw or the nut or drill a hole through, and look for ways to improve the working posture to get you in the most neutral position, and then you're able to select your hand tool. So you can see different types of grips here. The pinch or the power grip, that would be the pinch or the precision grip, that would be the type of grip you use when you write with a pencil, or the dental hygienist scales your teeth, or the worker in the bottom picture is using a pinch grip when they're cutting the chicken. And so that's when the object is manipulated with the distal ends of the finger. That's opposed to a power grip or a cylindrical grip. A power grip is when all 4 fingers are in contact with the object and the thumb slightly, and I say slightly, overlaps that index finger. That gives you the highest amount of muscle force. Now an oblique grip is very similar to a power grip, but what you're grabbing onto is larger than the circumference of your hand, and therefore that thumb doesn't overlap that index finger. When you're in a cylindrical grip or a precision grip, you're not able to actuate all the muscles in your forearm, and therefore it's a weaker grip. Okay, I said that wrong. When you're in an oblique grip or a pinch grip, you can't activate all the muscles in your forearm. The only time you can is when you're in a true power grip, and that's when all four fingers are in contact with the object, as well as the thumb, and the thumb slightly overlaps. And then a hook grip we don't usually use for hand tool use, and that would be the type of grip you grab onto when you're carrying a bucket or some plastic bags home from the grocery store. A power grip is 5 times stronger than a pinch grip. This means you generate the same amount of muscle force holding a 2-pound object with a pinch grip as you do holding a 10-pound object with a power grip. Simply increasing the diameter of the hand tool from a pinch grip to a power grip, or decreasing it from an oblique grip to a power grip, can decrease the muscle force required to actuate the tool or be able to do the job. %80 of the population is right-handed, which means that 15% of the population are left-handed. And it's really nice if you're able to provide to them tools that can be used with either hand, which is very challenging. But this also allows somebody to use their non-dominant hand if their dominant hand gets tired, or special tools for right and left-handed users. The handle of the tool is a natural extension of the hand, and it's your main interface between the worker and the tool. All the forces associated with the task, so whether it's the force required to squeeze the trigger or the force required to push the drill through the piece of wood, are transmitted between the handle and the hand. So if we can keep, as you can see here in this picture, if you can keep the wrist straight and the point of application of the tool in line with the wrist as much as possible, this is going to minimize the strain on the worker's wrist. When they have to deviate their wrist, that puts them in an awkward posture. Muscles have to work much harder. I'm going to go back 1 second here. Also, you can see that the shape of the handle should be at about a 75-degree angle, because if you take your hand right now and you close it like you were wrapping it around the handle, you can see that your pinky extends in further than your ring finger and less so your index finger, and the one that you can curl the least amount is your pointer finger. And so you want to have a handle that's designed just like the natural shape of the hand. And you also have to consider the orientation in which you're working on. In the picture here, it isn't actually an inline tool. It's a pistol grip tool, but the worker is using it in an inline orientation, which is up and down, which is a great orientation because he's working on a horizontal surface. And this is where he's using 2 hands for power. So it's a really great picture here. He's in a mostly neutral posture. Little deviation around the ears, but that's okay. We can put up with that for short periods of time. This is a pistol grip tool, and pistol grip tools work better when you're in the vertical orientation, so as opposed to working on walls. And again, you can see here how wrists are kept mostly straight, and it's in line with the way the tool is going to be operated. This is a rivet gun. One of the things that you may or may not notice about this picture is if you take kind of a close look in this area right here, that's where the pneumatic or the air comes into contact with the tool. And really we have to be careful here with our maintenance and make sure that those connections are tight and well lubricated, because if the air leaks out in this area, the cold air is exhausted right onto the worker's wrist. And as we know, cold temperatures are a contributing factor for the development of work-related musculoskeletal disorders. So that's one of the reasons why wearing gloves is such a good example when working with hand tools. It may not, and really the evidence is not very favorable for vibration dampening gloves, actually dampening the amount of vibration transmission into the worker's hands. But gloves can keep the hands warm and dry, and that will help minimize the contributing factors. So you have to consider here, we're talking about considering where the working point of the hands is and which type of tool you'll be selecting, whether that's more of an inline tool, or a pistol grip tool. So what's wrong with this picture? This woman is using a speed wrench, so she's using a wrench that has a bent angle in it so she could speed around quickly, and she's holding it on the top, pressing it down so it doesn't lift off the nut. So handle shape and orientation. We want to make sure that the tool fits the hand so that it's not too small or too big for the hand, that if you have a tool in which you have to open, like the pliers that you see here in this picture, the span between this space should be no more than 3.5 inches. And that the task fits the tool. So here's an example. The study was done in the 1970s, and they took 2 groups of workers that were coming in to be trained to do electronics work. And the first group that's in the red got the traditional pliers, and you can see in using the traditional pliers that it creates quite a deviation in the wrist. Then the second group had the angled pliers, and you can see the bend here in the angled pliers as opposed to the straight pliers. So having an angle in the pliers eliminated the angle in the wrist. And over the 12-week training period, the percentage of workers who complained of signs and symptoms of hand problems, musculoskeletal disorders, was significantly greater for the work that was significantly greater for the group that was doing the work using the conventional pliers. So angles and tools can be helpful to reduce the angle that you actually have in your hand. And I just like this picture because it's a really big wrench. But what you can see here is this is a really good example of an oblique grip. All of his fingers and his thumb are in contact, but his thumb can't possibly overlap his index finger, as well as he's grabbing onto a square, hard, cold object as opposed to a round object that's shaped like the hand and has some kind of padding to keep his hands cool. And I just love the look on this guy's face right here. Okay, so this shows that pistol grip tools are really good when you have a short distance between the point of application and the point of the tool. They're very hard to use. For example, like if you have a really long drill bit on a really short pistol grip tool, it becomes much more difficult to use. Pistol grip tools are great for precision tasks, although you do get that highly repetitive motion of the index finger. Again, we want to have as much as possible this 70-degree angle here so that the tool is shaped like the natural shape of the hand. And the center of gravity, so that would be the heaviest part of the tool, should be on the top, and it should balance right there in the center of the hand. And so good posture is important when using hand tools. And this gentleman, although he's leaning slightly forward, that's okay because he's able to use the force of his body and push that into the tool when he's doing his job. So he's not just using his upper body strength. And here you can see that he has a nice straight wrist orientation. So inline tools, this is an example of an inline tool. Inline tools are great when you have highly repetitive workstations like processing areas where you have the same work that's being done over and over again because you can counterbalance them. They work good when you're on that horizontal surface. The diameter should be 1.5 inches for men and 1 inch and 1.3 inches for women, but right about 1.5 inches will pretty much get you there. That's the diameter for how big the tool is. One of the problems with inline tools is sometimes they spin in the hand, and so it's nice to have a thumb stop so that the tool will not spin in your hand. But they're really easy because you're able to counterbalance them. As far as handle length goes, the handle length should be long enough so that the entire hand is in contact with the tool. Here you can see that you're able to use two hands for power. And again, taking a look at where that exhaust is and making sure that you have no air leaks in that exhaust. And as much as possible, you really want the forces distributed over a wide area and not over a small area. Again, all four fingers and the thumb are in contact with the tool. Our gripping surface, again, we took in the picture on the bottom, we took the scribe and we put a handle on it. We made it easier for people to grip. You'd like to encourage the use of a flange or a thumb stop because it helps to increase forces, increase the amount of force that you can feed. So it decreases the amount of forces inside the hand and distributes the forces over a wider area. You want to avoid cutouts or specially shaped tools because all people's hands aren't the same size, and sometimes you force them into the grooves, and that isn't necessarily a good thing. And again, you can see in the picture for the dental hygienist tools that we have a padded edge that increases the diameter, makes it easier to grab onto than a metal tool, which is smaller diameter and, of course, cold in the hand. If you can find tools that have some kind of rubber or plastic coating on them, it can help to soften vibration transmission as opposed to a metal tool. If a plastic material will usually provide a higher coefficient of friction, which means it'll prevent the tool from spinning or slipping in the worker's hands. And also, it creates a barrier between hot and cold environments. So here you can see the two spoons. Some tools, some tasks just simply require a heavier tool, such as this gentleman using this drill. He really should be using a longer handle drill, so he wouldn't be in this particular orientation, but this is probably the best drill that he can get. The tool is really heavy because you need the weight of the tool to be able to drive through the medium in which he's trying to push through. Here you can see he's got two handles on the tool. This tool really should be used in a, he should be holding the tool like a pistol grip tool instead of being bent over quite so far. The problem with heavier tools is sometimes they create some static muscle loading from holding on to the higher level of tools. But lighter tools aren't always necessarily good for accomplishing a task, especially if you need that driving force created by the weight of the tool. So heavier tools are anything that's more than 5 pounds or has to be used for greater than 4 hours a day. And it's good if you can counterbalance these tools somehow. As far as counterbalancing precision tools, any tool that's heavier than a pound should be counterbalanced. And of course, you can provide two handles, which helps to decrease the amount of forces on any one hand. And so either now or later on, if you go back to Moodle, there's a link there that shows you some really neat counterbalance tools by a company called Epipause Incorporated. And they not only counterbalance their tools with unbelievably flexible gimbals, but they create some exoskeletons that totally relieve the forces from the worker's hands. So your counterbalances, this is an example of where this poor gentleman could really use a counterbalance tool. This impact wrench is well over 25 pounds. And the problem with the impact wrenches are when you reach that set point, that's when that tool starts to kick up or kind of kick in your hand, and you create that impulse or that impact on the worker's hand. And here we're just counterbalancing the tool with an engine hoist or a cherry picker. And again, this is a website that's up there for you to take a look at some really great technology. We were putting this technology in place when I was working with the United States Navy. Some other ways that you can counterbalance tools is to do it with your hose reels, so you get your reels off the floor as well. And that's great to keep your hoses from getting damaged from being on the floor. It eliminates your tripping hazards, as well as helps to counterbalance the tool. And this is a really neat item. This is called a torque reaction bar. And so it works really nice. Again, this is an impact wrench. When that wrench reaches its set point, meaning that the nut is tightened down as far as it would go, the impact wrench twists and in the worker's hand. And it could be that impact in combination with the vibration that is causing, some of the issues that you get, work-related musculoskeletal disorders of the hand, the wrist, the elbow, the shoulder. So this torque reaction bar, it just simply sets on one of the other nuts or a hard point on whatever it is that you're working on. And when the tool reaches that set point or the nut is tightened down all the way, instead of the reaction going into the worker's hands, it's transferred into the torque reaction bar. So some other miscellaneous tool features that you'll find out there, quite honestly, Atlas Copco makes some of the best tools in the business. And a little bit more expensive, but they have tools with interchangeable handles on them, so you can have a larger handle for a male worker versus your female workers. Remember, your female workers are usually smaller, they have smaller hands, and they're using a tool that if it's too big for them, because the handle's too big, not necessarily the weight of the tool, they have to increase the amount of force required to just hold on to it. And that increased force, like that increased pressure, increases the transmission of the vibration from the tool into the worker's hands. And then some specially angled tools or tools that are spring-loaded so they open for you so you don't have to constantly flick that tool open. So what's wrong with these pictures? Do you know? The first picture, if we're using these gloves for anti-vibration properties, if you don't have your fingers protected, they're not doing you any good. The second picture, if somebody's modifying a tool, there's probably something wrong with it to begin with. Oop. We weren't supposed to look at those pictures. Sorry about that. I'll just skip over here. So what is hand-arm vibration? Hand-arm vibration occurs when the hands and arms are exposed to vibration. Sources of vibration include powered hand tools. Powered hand tools are machines such as leaf blowers. You have floor buffers. You have weed whackers, jackhammers, drill motors, saws, reciprocating saws. I mean, there's all sorts of different ways in which your hands or your hand is in contact with the vibrating source. And so workers who are frequently exposed to tools that vibrate may be at a higher risk for developing hand-arm vibration syndrome. So there are three different characteristics of vibration. And one way to look at it, you can really take an entire class on vibration exposure, is by looking at a person swinging back and forth. So how high the swing is going, that's the magnitude of the vibration. So whether it's a high, whether it's a high vibration tool versus a low vibration tool, so that's the magnitude of the vibration. The frequency would be how fast the vibration's going, whether it's a high frequency or a low frequency. And then the duration would be how long a person is actually swinging. So those are three important characteristics. And this table came out of the American Conference of Governmental Industrial Hygienists Guidelines for hand-arm vibration exposure. And you can see that any tool that exceeds 12 meters per second squared, so that's your acceleration over time, meters per second squared, or it's actually your velocity over time, turning it into an acceleration, that workers should be exposed for less than 12 hours a day. So some ways, if you don't have vibration measuring equipment inside of your facilities, one thing you can do is go back to the tool manufacturer and look at the specs and look what the vibration characteristics of the tool were when the tool left the manufacturer. Then you can see whether, on a general, very qualitative basis, whether workers are overexposed or not. And remember that that's in the best possible maintenance that the tool could be in when the tool left the manufacturer. And there's other things that can counterbalance whether that tool is actually operating at that vibration level or not. So here again from Atlas Copco, they tell you exactly that the vibration of this tool is 7 meters per second. Should have had a squared in there. I don't know why it doesn't have the squared. And if we went back to our table, we can see that somewhere workers should be less than 4, less than 5 hours a day if they're using that particular tool. So it's just one way to take a look at how you can look at vibration exposure. So vibration-induced white finger or Renault syndrome. Renault syndrome is also naturally occurring as well. It's the contraction of blood vessels in the hand which cause a fall in blood volume or decreased circulation. So when the tool is vibrating in the worker's hands, it stops the blood from getting to the ends of the blood vessels. So you have this drop in circulation and this drop in volume. When you start to have the blood vessels dying off and a loss of circulation over a long period of time, just not the period of time in which you're using the hand tool, then the fingers turn white and you actually have the loss of sensation. You can have thickening of the fingers in this particular area. And once you develop hand-arm vibration syndrome or Renault syndrome, the condition is always there. It never gets any better. You can't recover from it. Now you can stop the pain or the symptoms from coming on by not being exposed to cold, wet, or vibrating environments anymore. So it is an irreversible condition. Usually people that are in stage 1, and there's some background information I'll post on Moodle so you can get some more information on there. People initially report tingling, numbness, or coldness after an exposure. It's really very much the same as like if you've ever had frostbite before. Once you have it, that area is always sensitive to cold or wet environments. They have prolonged exposure can then decrease your flexibility and increase your pain and your swelling, and you get thickening of the skin as well as dying off of the blood vessels. So some ways that we can reduce vibration exposure is, of course, just to reduce the amount of time people are in contacting with the vibrating source. Buy tools that have the vibration dampened internally. Dampen the transmission from the tool to the hand by putting some kind of barrier in place, such as having a plastic handle on a tool. Remote operation of the tool, that would be great. We talked about decreasing one's daily exposure. And remember proper and timely tool maintenance. If you have air hose that are leaking and you're not getting the right PSI at the tool, it's not operating at the correct revolutions per minute. Therefore, it's operating slower. It might be less efficient. The vibration levels can go up significantly. Or therein, if the tool is running slower, people might have to use it for a longer period of time. If the right abrasive material or the right cutting tool isn't available and they're using duller sanding paper, it's already worn out, or a cutting edge that isn't sharp, then of course workers are going to be working much longer in. And although we talked about hand tools, you can take this into a laboratory environment as well. And although they're not using power tools, when they're using maybe pipettes over and over again, can you have a pipette that has a button control instead of manually squeezing and opening the pipette? Can you pipette 4 things at one time instead of 2? Are workers in a neutral posture when they're using the pipette? So you can take this from hand tools and expand it into whatever area. Remember, whatever's in the hand, it's a natural extension of it. We want to keep the working point of the hands there and about elbow height, slightly higher for precision work, slightly lower for heavy work, and to always maintain that tool. So how can we reduce our risk? Well, we ensure that workers keep warm at work, especially their hands. Warm gloves and extra clothing can be used. If you're make sure that gloves fit the hands. Gloves that are too tight decrease circulation. Gloves that are too big, you have to fight against them. If you're going to buy a vibration dampening glove, make sure it's in compliant with the ISO standard. And as a professional ergonomist, I'm somewhat against them because research hasn't really shown that they decrease the exposure transmission significantly into the worker's hands. One of the reasons behind that is when you're wearing a vibration dampening glove, it's got a big pad in it like an innersole. You're putting that between the tool and your hand, and so now you're functionally making your hand smaller, and some workers have to grip that much harder. You can provide exercises to improve circulations and maybe encourage your workers to at least not smoke at work if they're going to smoke, because it decreases your circulation and your oxygen content. So there's some additional information posted on Moodle about hand tools. You got a great assignment to do. Pick a tool to evaluate, and I hope you have a splendid day.